Our solar system holds secrets that defy everything we think we know. Scientists have catalogued 25 bizarre phenomena right in our cosmic backyard, from mysterious signals to impossible storms that remain completely unexplained. By the end of this journey, you will discover the most perplexing cosmic puzzles that keep astronomers awake at night. Why does a perfect hexagon rage at Saturn's pole? And what force is carving a strange cliff at the edge of our planetary neighborhood? What single cosmic mystery do you find most compelling on a quiet August evening in 1977? A radio telescope in Ohio picked up a burst of energy so powerful and so unusual that the astronomer who discovered the data printout was moved to circle it and simply write, "Wow." This was the WOW signal, a 72-second radio blast that seemed to scream from the depths of space. It came from the direction of the constellation Sagittarius, a region crowded with stars, and it was broadcast on a very specific frequency, one that scientists associate with the natural emission of hydrogen, the most common element in the universe. It is a frequency often considered a logical channel for anyone or anything trying to get our attention. The evidence was a string of letters and numbers on a continuous computer printout, 6EQUJ5, a code representing the signal's incredible intensity. It was 30 times stronger than the background noise of space, a spike that came from nowhere and vanished just as quickly. Despite decades of listening, we have never heard anything like it again from that spot in the sky. So what was it? Some argue it could have been a natural event we do not yet understand, perhaps a comet we did not know about at the time, though that theory has serious flaws. Others wonder if it was a one-time malfunction of the telescope itself, a cosmic glitch. But the most haunting possibility is that for just 72 seconds, we intercepted a transmission not meant for us. A message that traveled across the light years, arrived by chance, and then was gone, leaving behind a single, tantalizing piece of paper and a question that has echoed for decades. This solitary event reminds us that the cosmos is capable of profound surprises, but the solar system holds even more peculiar enigmas much closer to home. While the WOW signal remains a solitary whisper from deep space, another mystery from the same era captured the public imagination with a powerful image. In July 1976, NASA Viking 1 orbiter was mapping the Martian surface when it snapped a picture of the Cydonia region. The photograph revealed what looked unmistakably like a giant human face staring up from the red desert. Stretching nearly 2 miles across with what appeared to be symmetrical eyes, a nose, and a mouth, the formation ignited a firestorm of speculation. Was this a monumental artifact, a relic of a long-lost Martian civilization, deliberately built for us to find? The idea of a face on Mars was so visceral, so compelling, that it bypassed logic and spoke directly to our deepest hopes for cosmic companionship. It felt like a message carved in stone, but science, of course, demands a closer look. Decades later, new orbiters with far more powerful cameras, like Mars Global Surveyor, returned to Cydonia. The high-resolution images they sent back told a very different story. The iconic face was gone, replaced by the clear, sun-baked features of a natural mesa, a flat-topped hill heavily eroded by wind and time. The haunting symmetry vanished under the harsh, direct light of a Martian midday, revealing a chaotic, rocky landscape. Our brains are wired to find patterns, especially familiar ones like faces, in random data, a psychological phenomenon called pareidolia. We see the man in the moon or a dragon in the clouds. The face on Mars was a perfect, if colossal, example of this, yet a sliver of mystery remains. Why did this particular hill erode into such a distinct, face-like shape from that one specific angle and under that specific lighting? The combination of shadow and perspective that created the illusion was so perfect it feels almost like a cosmic coincidence. The story of the face on Mars is a lesson in how easily we can project our own stories onto the blank canvas of another world. and a reminder that reality, when examined closely, is often stranger than any fiction we could invent. Mars may be a world of silent deserts, but it occasionally speaks in a language of gas. The whispers come as methane, a simple molecule that on Earth is overwhelmingly a byproduct of life. Rovers like Curiosity have repeatedly sniffed out tiny, fluctuating bursts of this gas in the Martian atmosphere. These are not steady leaks, but sudden, mysterious plumes that appear and vanish without warning. One day the air holds a faint trace, and the next it has spiked to 10 times the background level, only to disappear completely just as scientists begin to celebrate. This sporadic nature is the heart of the mystery. If the source were a constant, steady process, we would expect to see a permanent, thin haze of methane. Instead, we see sharp, localized bursts, as if something is actively and intermittently producing or releasing it, then swiftly scrubbing it from the air. So where is it coming from? Scientists are locked in a fundamental debate, split between two compelling possibilities. The first is geology. Methane can be produced by subterranean rocks reacting with water in a process called serpentinization. It is a purely chemical explanation, suggesting that deep beneath the Martian surface, ancient reservoirs of the gas are occasionally punctured, allowing a puff to escape into the sky. The other possibility, the one that sends a shiver of excitement through the scientific community, is biology. On our planet, the vast majority of methane is belched out by living organisms from microbes to cattle. Could the red planet be hiding a subsurface biosphere, a vast network of microbial life eking out an existence in dark, watery aquifers, releasing its metabolic waste into the atmosphere above? The problem is that Mars should not have methane for long, as solar radiation quickly breaks it apart. The fact that we detect these sudden surges means the gas is being released recently and nearby. Something is actively producing it right now. This makes the methane not just a gas but a ghost, a tantalizing clue that points to either a fascinating geological world we do not fully understand or the first fragile signature of life beyond Earth. It is a cosmic whodunit with the entire planet of Mars as the crime scene. Far from the dusty plains of Mars, a completely different kind of mystery whirls in the frigid darkness above Saturn. A perfect hexagon, wider than 2 Earths, encircles the gas giant's north pole. This is not an artist's impression or a fleeting cloud formation. It is a permanent, colossal storm, a geometric vortex that has raged for at least 40 years and likely much longer. When the Voyager probes first glimpsed it in the 1980s, scientists could scarcely believe the data. Clouds on planets tend to form ovals or chaotic spirals, not pristine, 6-sided polygons. The Cassini mission later confirmed it was not an illusion, capturing stunning, high-definition images of this impossible structure. The hexagon is a highway of winds, a jet stream screaming at over 300 miles per hour, tracing its sharp, unwavering edges. How can such a violent, chaotic system produce a shape of such perfect, stable geometry? The answer may lie in the strange physics of fluids. Imagine a cup of coffee with a spoon stirring it gently. You see circular motion, but if you stir that coffee much faster, the fluid can suddenly snap into a different state, forming stable, geometric waves. Some laboratory experiments have recreated similar polygonal shapes in spinning fluids. The theory suggests that deep inside Saturn, different layers of atmosphere are rotating at different speeds. Where these layers meet and shear against each other, the turbulence might naturally organize itself into this 6-sided pattern. It is a standing wave frozen in place by the planet's furious rotation. Yet, the sheer scale and stability of Saturn's hexagon are unlike anything we can fully replicate. Why 6 sides and not 5 or 7? Why has it remained so perfectly locked for decades, unperturbed by the planet's other titanic storms? This is not just a weather pattern, it is a fundamental lesson in how nature can impose order upon chaos, a cosmic artwork painted with the invisible brush of physics, reminding us that the laws we know can create wonders we have yet to even dream of. While Saturn's hexagon demonstrates geometry on a planetary scale, the universe sculpts similar precision among the stars. In the constellation Monoceros, a dying star known as HD 44179 is encased by one of the most bizarre structures ever seen, the Red Rectangle Nebula. Its name comes from its appearance in early images, which showed a strikingly geometric, box-like form glowing with a deep crimson hue. Unlike the chaotic, billowing clouds of most nebulae, this one seems to have been drafted with a cosmic ruler. The secret to its shape lies in its bipolar structure. Imagine two ice cream cones placed tip to tip, with the central star hidden right at the point where they meet. As the star dies, it expels gas and dust in two powerful, opposing jets. These outflows create the conical shapes, and from our vantage point on Earth, we are looking directly at the side of this double cone, which frames a perfect dark rectangle at its heart. But the geometry does not stop there. Etched across the nebula's red glow are a series of evenly spaced horizontal bars like the rungs of a ladder. These are not solid structures but shock waves. As the central star pulses and ejects material in fits and starts, it creates concentric waves of dust that expand outward. We see these waves as a sequence of rungs, a fossil record of the star's final, rhythmic death throes. Perhaps the most profound mystery, however, is not the nebula's shape but what it is made of. The red glow itself is emitted by complex organic molecules known as polycyclic aromatic hydrocarbons. These are not signs of life, but they are the large, carbon-based building blocks that are essential for it. Finding them in such abundance and in such an orderly structure is like discovering a warehouse full of prefabricated parts for constructing something far greater. The red rectangle is more than a beautiful cosmic accident. It is a natural factory for the very ingredients that, in the right conditions, could one day lead to biology. It poses a silent question about how widespread these fundamental components of life truly are, and whether such geometric perfection is nature's preferred method for organizing the cosmos. The Red Rectangle Nebula demonstrates how nature can assemble complex molecules with geometric precision, but sometimes the cosmos delivers its messages with pure, unadulterated force. On the morning of June 30th, 1908, in a remote part of Siberia, a man sitting on the porch of a trading post was thrown from his chair. The sky split in two, he would later report, and a massive blast of heat scorched his shirt. This was the Tunguska event, a cataclysmic explosion estimated to be 1,000 times more powerful than the atomic bomb dropped on Hiroshima, flattened over 800 square miles of forest. 80 million trees were felled in an instant, their trunks pointing radially outward from a central point like spokes on a wheel. Yet, when expedition teams finally reached the site decades later, they found no crater. The epicenter showed standing, charred trees stripped of their branches, but the ground was utterly unscarred. It was as if the destructive force had never touched the earth. Witnesses hundreds of miles away described a blinding blue light moving across the sky, followed by a series of thunderous shocks that shattered windows and shook the ground. The night skies across Europe and Asia glowed for weeks, so bright that people could read newspapers outdoors at midnight. So what could unleash such devastation without leaving a single trace of itself? The leading theory points to a cosmic intruder, a stony asteroid or a fragile comet roughly 200 feet wide. Scientists believe it never actually struck the planet. Instead, it tore through the atmosphere at over 30,000 miles per hour, and the intense pressure of its descent caused it to explode in a blinding flash of heat and energy some 3 to 6 miles above the ground. This airburst would have released the energy equivalent of a nuclear bomb, generating a superheated shockwave that incinerated the forest below and blew the trees flat. But the lack of any definitive fragments has kept the door open for more exotic explanations. Some have proposed a small black hole passing through the Earth, though there is no evidence for such an exit wound. Others have suggested an encounter with a chunk of antimatter, which would annihilate itself in a titanic release of energy upon contact with our normal matter. The most enduring mystery is the absence of the smoking gun, the irrefutable piece of the object that caused it all. The Tunguska event stands as a stark, sobering reminder that our planet exists in a cosmic shooting gallery, and that some of the most powerful forces in the solar system can arrive without warning and leave without a trace. The Tunguska event proved that cosmic forces can arrive without a trace, but another mystery hides in the perpetual twilight at the very edge of our planetary system. Far beyond the orbit of Neptune, in a vast, dark realm of icy debris known as the Kuiper Belt, astronomers have found a cliff. This is not a physical wall of rock, but a sudden, dramatic boundary in space itself, a place where the population of objects plummets to almost nothing. It is as if the solar system simply ends, defying every prediction of how it should have formed. Our standard models suggest this belt of frozen leftovers should extend smoothly for billions of miles, gradually thinning out as it merges with the emptiness of interstellar space. Instead, we see a sharp, clean edge, a cosmic shoreline where the ocean of objects drops off into an abyss. What could have carved such a distinct border in this primordial graveyard? One of the most tantalizing theories involves a ghost, a world we have yet to lay eyes on. Astronomers call it Planet 9, a hypothetical giant planet perhaps 10 times the mass of Earth lurking in the distant dark. Its immense gravitational pull, the theory goes, could have shepherded all the objects inward, clearing out a vast swath of space beyond its own orbit and sculpting this abrupt cliff. It is a compelling idea, a hidden architect shaping the solar system from the shadows. Yet other scientists point to a more mundane possibility, an observational bias. Perhaps our telescopes are simply not powerful enough to see the faint, distant objects that lie beyond this perceived edge. We are mapping a dark forest by the light of a single match, and we may be mistaking a small clearing for the end of the woods. But the cliff appears so stark, so definitive, that many find it hard to believe it is merely an illusion. The Kuiper Belt Cliff is a fundamental challenge to our story of the solar system's birth. It suggests that a dramatic, unknown event reshaped our cosmic backyard long after the planets formed, leaving behind a silent, structural clue. Was it the gravitational hand of a rogue planet, or is the universe presenting us with a cosmic illusion, testing our ability to see what is truly there? Deep in the silent expanse of the outer solar system, two robotic pioneers began to drift off course. Pioneer 10 and Pioneer 11, after their triumphant missions to Jupiter and Saturn, were now speeding toward interstellar space. Yet as scientists tracked their faint radio signals, they noticed something deeply unsettling. Both spacecraft were slowing down. It was an almost imperceptible deceleration, a tiny, constant tug back toward the sun, as if an invisible hand had reached out and was gently holding them back. This was the Pioneer anomaly, a deviation so small it was measured in nanometers per second squared, yet it defied the pristine laws of gravity for over a decade. How could two separate spacecraft, billions of miles apart, experience the exact same mysterious drag? The hunt for an answer became a monumental exercise in cosmic forensics. Teams of researchers spent years sifting through decades of old data, searching for any overlooked detail. Perhaps it was the gentle push of dark matter or a flaw in our understanding of gravity itself. They modeled the gravitational pull of every known object from the planets to the Kuiper Belt, but the math never added up. The solution, when it finally emerged, was not in the void of space, but in the spacecraft themselves. These probes were powered by radioactive generators, and that process created heat. Engineers realized this heat was radiating away from the craft unevenly. Because of Pioneer's distinctive design with a large dish antenna shadowing the main body, more heat was escaping from the back of the spacecraft than the front. This created a tiny but constant photon thrust. It was the equivalent of light pushing back, a minuscule pressure from the spacecraft's own warmth that acted as a perpetual brake. This thermal recoil force accounted for most of the anomalous deceleration, a brilliant solution born from meticulous engineering, yet a whisper of the mystery persists. When all the calculations are complete, a tiny fraction of the slowdown remains unaccounted for. It is a discrepancy so small it might yet be a rounding error in our complex models, or it could be the faint signal of something entirely new. The Pioneer anomaly taught us a profound lesson that even in the cold vacuum of space, the most subtle forces can have dramatic consequences, and that our own creations can sometimes reveal the universe's quietest secrets. Our own planet holds a paradox that challenges our understanding of its very origins. Billions of years ago, when life was first taking hold on Earth, the Sun was a much weaker star, shining with only about 70% of its current brightness. By all rights, our young world should have been a global snowball, a frozen wasteland locked in ice from pole to pole. Yet the geological record tells a completely different story. Ancient rocks show clear evidence of liquid water, from riverbeds to ocean sediments, dating back to this very period. How could a faint sun have warmed a planet enough for flowing water and eventually life to exist? This is the faint young sun paradox, a fundamental puzzle in planetary science. The most widely accepted solution points to Earth's early atmosphere, which was likely a thick, toxic blanket of gases like methane and carbon dioxide. These are potent greenhouse gases, trapping the sun's feeble heat with far greater efficiency than our modern atmosphere does. It was a planetary pressure cooker, creating a cozy haven against the cosmic cold. Another piece of the puzzle may have been the planet's face itself. With no green plants or continents as we know them, the early Earth was probably much darker, absorbing more of the sun's precious light rather than reflecting it back into space. This combination of a supercharged greenhouse effect and a darker surface could have provided the extra warmth needed to keep the oceans liquid. Solving this ancient mystery is not just about our past, it is crucial for our future. It teaches us how delicate the balance of a planet's climate truly is, and how many factors, from air composition to surface color, play a role in creating a habitable world. This understanding directly shapes our search for life on distant exoplanets, reminding us that a star's power is only part of the story. The true magic might lie in the world that orbits it. The same forces that shaped our young Earth left their mark on its constant companion, but the Moon holds a secret written in stone. Samples brought back by the Apollo astronauts revealed a stunning truth that the lunar surface is magnetized. Billions of years ago, the Moon had a magnetic field, a protective shield perhaps as strong as Earth's is today. This is a profound cosmic contradiction. A global magnetic field is generated by a churning, molten metal core, a planetary dynamo. For a small world like the Moon to have one, its interior would have needed to rage with a ferocious heat that simple models say it should have lost almost immediately after its violent formation. So what powered this ancient lunar dynamo? One leading theory points to a dramatic orbital dance. In its youth, the Moon was much closer to Earth, and our planet's immense gravitational pull would have stretched and squeezed its rocky interior through tidal forces. This constant flexing, much like repeatedly bending a piece of metal until it grows hot, could have generated the internal friction needed to keep the core molten and stirring for over 1 billion years. It is a beautiful idea, a magnetic field born from a planetary embrace. Yet other scientists propose a more catastrophic origin. Perhaps the dynamo was jump-started by colossal impacts that rocked the early solar system. A giant strike could have shaken the Moon's interior so violently that it disrupted the core's stable layers, triggering a temporary but powerful period of churning. The very rocks that record this magnetic history offer another clue. The field did not fade away slowly. It appears to have switched off abruptly around 1 billion years ago. Why did it stop so suddenly? Did the moon's core finally cool and solidify, or did its orbit change enough that Earth's tidal heating could no longer reach the interior? The ghost of this magnetic shield challenges our most basic ideas about how small, rocky worlds live and die. It suggests that a world we see as geologically dead was once a dynamic, energetic place protected by an invisible force field that vanished as mysteriously as it appeared. While our moon lost its magnetic shield long ago, the toxic world next door exhibits a swirling power of its own. High above the acid-laced clouds of Venus, a permanent hurricane rages at the South Pole. This is not a simple spiral, but a colossal, double-eyed vortex, a storm with two distinct centers that dance around each other in an intricate and terrifying ballet. The European Space Agency's Venus Express orbiter first mapped this structure in stunning detail, using infrared eyes to peer through the planet's thick veil of clouds. What it revealed was a fluid dynamic nightmare, a vortex that constantly shifts, splits, and reforms, defying our expectations of how planetary weather should behave. On Earth, a polar vortex is a single, broad area of circulating cold air. On Saturn, we see a stable geometric hexagon, but Venus presents something entirely different, a dynamic double vortex that seems to be in a state of perpetual, chaotic reorganization. The two eyes of the storm are not static. They change shape from hour to hour, sometimes appearing as two separate, squirming ovals, and at other times merging into a single, distorted figure 8. This constant state of flux is the central mystery. What forces drive such instability in a storm that is, itself, a permanent fixture of the planet's climate? The answer may lie in the sheer violence of Venus' atmosphere. The entire planet is engulfed in a phenomenon called superrotation, where the upper atmosphere screams around the globe at hundreds of miles per hour, completing a full circuit in just 4 Earth days, while the planet itself rotates sluggishly once every 243 days. This hurricane force wind smashes into the mountain-high Maxwell-Montes range, creating atmospheric waves that ripple around the planet and converge at the poles. It is at these poles that the raging winds are funneled downward, twisting and colliding to form these bizarre double-core vortices. Scientists have created computer models that can simulate a double vortex, but no model has perfectly recreated the frenetic, shape-shifting chaos that Venus Express observed. The storm seems to feed on its own turbulence, a self-sustaining engine of violence. Why does it have two hearts instead of one? How does it maintain its structure without dissolving into random turbulence? This is more than just a storm. It is a laboratory for extreme physics, a window into the chaotic forces that can dominate an entire world, and a reminder that even in our own neighborhood, the weather can be utterly alien. The chaotic weather of Venus is a stark reminder of the forces that shape worlds, but some of the solar system's greatest structures are defined by a profound emptiness. Far beyond the Kuiper Belt's mysterious cliff, our sun's dominion is thought to end in a vast spherical shell of frozen relics known as the Oort cloud. This is not a place you can see or visit. It is a theoretical realm of pure gravity, a ghostly archive holding perhaps trillions of icy objects in a tenuous embrace. The greatest puzzle of the Oort cloud is not what it is, but how it possibly got there. These are primordial objects, leftover building blocks from the formation of the solar system. Yet standard models say they formed much closer to the Sun, in the warmer, denser region near where the giant planets orbit today. So how did they end up in this impossibly distant spherical shell, a light year from the Sun and halfway to the next star? The answer involves a cosmic game of gravitational pinball. In the solar system's violent youth, the newly formed giant planets, particularly Jupiter and Saturn, acted like massive slingshots. Their immense gravity would have hurled countless smaller icy bodies into wildly elongated orbits, flinging them in all directions, but this alone would not create a stable spherical cloud. The objects needed to be shepherded and contained, and for that they required outside influences. Two primary forces are thought to have sculpted this diffuse halo. The first is the gentle but relentless pull of the Milky Way itself. The galaxy's collective gravity creates tidal forces, much like the Moon's pull on Earth's oceans but on a vastly larger scale. These galactic tides work over billions of years to circularize the orbits of the scattered objects, pushing them into a more spherical distribution. The second force comes from the Sun's ancient neighbors. In its early journey around the galaxy, our Sun was not alone. It was born in a dense cluster of stars, and close flybys from these sibling stars would have further perturbed the orbits of the scattered icy bodies, pulling them into the vast spherical reservoir we theorize today. This is why we have no direct observations of the Oort cloud. Its objects are so distant and dark they reflect virtually no sunlight, and their orbits are so long that a single year for one of these bodies could span millions of our own. We only catch glimpses of them when a stellar nudge sends one tumbling inward, flaring into life as a long-period comet with a tail that stretches across the sky. The Oort cloud is therefore a monument to our solar system's dynamic past, a frozen borderland shaped by the hands of planets, stars, and the galaxy itself. Jupiter's Great Red Spot is a perpetual hurricane large enough to swallow our entire planet, a vortex of fury that has churned for centuries. This colossal storm is the most iconic feature in our solar system, a swirling crimson eye staring out from the cloud tops of a gas giant. For at least 400 years since astronomers first pointed their rudimentary telescopes at Jupiter, this spot has been seen raging in its southern hemisphere. Yet this ancient storm is not what it once was. Time-lapse images from Voyager, Galileo, and Juno reveal a startling transformation. The Great Red Spot is shrinking. A century ago, you could have fit 3 Earths side by side within its turbulent boundaries. Today, it is barely wide enough to contain one. The storm appears to be condensing, growing taller even as it narrows, like a figure skater pulling in her arms to spin faster. So what fuels such an enduring cataclysm, and why is it now fading? The storm is essentially a massive high-pressure system, an anticyclone where winds scream counterclockwise at over 400 miles per hour. Unlike hurricanes on Earth, which draw their energy from warm ocean waters, the Great Red Spot has no such fuel source. It is a self-sustaining atmospheric engine, powered by the internal heat of Jupiter itself, and fed by the constant merger of smaller storms that it consumes. It is a predator maintaining its dominance by devouring its competition. The source of its famous red hue is another enduring puzzle. The color likely comes from complex chemical compounds being dredged up from deep within Jupiter's atmosphere and exposed to the sun's powerful ultraviolet light. One theory suggests these are sulfur or phosphorus-bearing molecules that change color when cooked by solar radiation, a cosmic dye created in the upper layers of the storm. Yet the exact recipe remains unknown, a secret locked within the spot's churning chemistry. The storm's gradual shrinking raises the ultimate question of its fate. Will it continue to condense and intensify, or is it slowly dissipating, destined to unravel into a pale memory over the coming decades? Some models suggest it could eventually vanish, while others propose it might stabilize at a smaller size. Watching this giant's slow transformation is like witnessing the life cycle of a cosmic titan, a reminder that even the most permanent-looking features in our solar system are transient, dynamic, and filled with secrets we are only beginning to understand. While Jupiter's great storm is slowly fading, a star over 1,000 light-years away was caught in the act of vanishing before our very eyes. KIC 8462852, better known as Tabby's star, presented astronomers with one of the most baffling light shows ever recorded. The Kepler Space Telescope, designed to hunt for planets by spotting the tiny, regular dips in starlight caused by an orbiting world, found something entirely different here. Instead of the predictable, repeating dimming of a planet, Tabby's star dimmed in wild, chaotic, and dramatic ways. It would drop in brightness by a tiny fraction, then plunge by a staggering 22%, as if a colossal, jagged object was drifting in front of it. These dips were not periodic. They were erratic, asymmetrical, and utterly unprecedented. Nothing in nature, from a simple planet to a cloud of dust, was known to behave this way. The strangeness of the data demanded extraordinary theories. Some scientists proposed a truly colossal swarm of comets, hundreds of thousands of them, breaking up and casting intricate shadows. Others pointed to dust from a catastrophic planetary collision, a cloud so vast and uneven it could explain the bizarre light patterns. But the most captivating idea, the one that captured the public imagination, was the notion of an alien megastructure. Imagine a Dyson swarm, a vast collection of energy-capturing panels built by an advanced civilization, orbiting its sun in a chaotic array. Such a structure would indeed block light in irregular, hard-to-predict ways, matching the observed data in a way natural phenomena struggled to. The hypothesis was not that it was aliens, but that for the first time we had data we could not immediately explain, and an advanced intelligence was a testable, if remote, possibility. Follow-up observations poured in, scrutinizing the star across every wavelength of light. The key clue came from the dimming itself. When the star dimmed more in blue light than in red light, it pointed squarely to a natural culprit: dust. Small dust particles scatter blue light more effectively, so a cloud of fine dust would cause exactly this kind of color-dependent dimming. The alien megastructure hypothesis began to fade, replaced by a more nuanced but still mysterious natural explanation. The current leading theory suggests that the star is surrounded by a vast, uneven ring of dust and debris, possibly from the breakup of a moon or a planet, creating a complex and evolving shadow play as it orbits. Tabby's star remains an enigma, a powerful lesson in scientific discovery. It showed us how the universe can produce signals so strange they push us to consider the impossible, and how the patient work of observation slowly pulls the most fantastic explanations back toward the natural, yet still wondrous world. The search for alien megastructures led us to distant stars, but then an interstellar traveler arrived in our own cosmic backyard. In October 2017, astronomers in Hawaii spotted a faint, fast-moving point of light that did not belong. They named it Oumuamua, a Hawaiian word meaning a messenger from the distant past. It was the first object ever detected that came from another star system, a visitor from the void between the stars. Its trajectory was a stark, hyperbolic arc, a path that proved it was not bound by the sun's gravity, merely passing through on its way to unknown destinations. The first surprise was its shape. Based on how its brightness changed dramatically as it tumbled end over end, scientists deduced it was highly elongated, perhaps 10 times as long as it was wide. It was not a roundish lump like most asteroids or comets, but a strange cigar or pancake-shaped object, unlike anything we have seen in our own solar system. Then came the real mystery. As Oumuamua sped away from the sun, its path could not be explained by gravity alone. It was accelerating ever so slightly, as if an unseen force was giving it an extra push. For a comet, this is normal behavior caused by icy material vaporizing in the sun's heat, creating a jet of gas that acts like a rocket engine. The critical detail, however, is that a comet's outgassing produces a visible coma, a fuzzy envelope of gas and dust around the nucleus. Oumuamua had no coma, no dust tail, no visible outgassing whatsoever. It was as dark and inert as a piece of rock, yet something was clearly pushing it. This was the paradox of its non-gravitational acceleration, a ghostly nudge with no apparent source. The scientific community split into camps. One side argued it must be a comet after all, an exotic one whose outgassing was made of pure water ice or other gases that did not carry much dust, making the jets invisible to our telescopes. The other side proposed it was a new type of object altogether, perhaps a fractal-like aggregate of dust known as a dust bunny, or a shard of a Pluto-like world shattered by a distant impact. The most provocative hypothesis came from Harvard astronomer Avi Loeb, who suggested we could not rule out an artificial origin. Could Oumuamua be a light sail, a piece of advanced technology from an alien civilization, using the pressure of starlight for propulsion? This would explain its unusual shape and its mysterious acceleration without a visible tail. While most scientists favor a natural explanation, the very fact that such a radical idea had to be considered highlights how profoundly strange this visitor was. Oumuamua is now gone, racing back into the interstellar dark, leaving behind a trail of questions and a fundamental change in our perspective. We now know that interstellar objects are constantly passing through our system, silent, enigmatic ships on an endless voyage, each one carrying the untold secrets of its home star. While Oumuamua was a fleeting visitor from the stars, one of our solar system's own moons is actively reaching out to us. Far out near Saturn's majestic rings, the small, icy moon Enceladus is screaming to be heard. For decades, it appeared as little more than a frozen marble, a ball of ice reflecting sunlight in the outer solar system's chill. Then the Cassini spacecraft arrived and its cameras captured something impossible. At the moon's south pole, magnificent plumes of water vapor and ice were erupting into space, firing from a series of deep fractures known as the tiger stripes. These were not random puffs of dust, but continuous, powerful geysers, shooting out over 100 miles above the surface, a silent, brilliant fountain against the blackness of space. Cassini did more than just watch. It flew right through these plumes, tasting their composition. The data revealed a stunning truth. These geysers are saltwater, rich with organic molecules like methane, propane, and acetylene. They are the direct samples from a vast global ocean hidden beneath dozens of miles of solid ice. This subsurface sea is not a frozen slush, but a liquid, churning body of water, holding more volume than all of Earth's Great Lakes combined. The question that immediately follows is the most profound one of all. What force could possibly keep this water liquid so far from the sun's warmth on a tiny world that should have frozen solid eons ago? The answer lies in a relentless gravitational tug of war. As Enceladus orbits Saturn, the giant planet's immense gravity squeezes and flexes the moon's rocky core. This process, known as tidal heating, generates immense friction and warmth from the inside out. It is this internal furnace that prevents the global ocean from freezing, melting the ice from below and creating the pressure that forces the water up through the cracks in the icy shell. The presence of liquid water, a source of heat, and a rich cocktail of organic chemicals creates an environment that meets all the basic requirements for life as we know it. These are not just icy volcanoes, they are direct vents from a potentially habitable world. Could simple microbial organisms be thriving in that dark, salty ocean, fueled by chemical energy from hydrothermal vents on the seafloor, much like life around vents in Earth's deepest oceans? Each sparkling geyser particle that escapes Enceladus and joins Saturn's faint E-ring carries with it a piece of that answer. We have not yet found life there, but we have found its address, a hidden ocean on a small, active moon beckoning from the dark. Our solar system holds a world that spins on its side, a planet that has literally fallen over. Uranus rolls around the sun like a colossal blue marble, its axis tilted a staggering 98 degrees. This is not a slight lean like Earth's 23-degree tilt that gives us our seasons. This is a world that orbits the sun with its poles pointing almost directly at it, a fundamental reorientation that affects everything from its magnetic field to its bizarre, decades-long seasons. A single day on Uranus is a chaotic affair, but a single year is an epic cycle of extreme light and dark. For 21 Earth years, one pole is bathed in continuous sunlight, while the other half of the planet endures a frigid, pitch-black winter. Then, as it continues its 84-year orbit, the roles reverse. The Sun swings over the equator, creating a period of more normal days and nights before plunging the opposite pole into its own 42-year-long summer. Imagine a summer that lasts for generations, followed by an equally long winter. The entire climate of the planet is built around this radical cycle, a rhythm of sunlight unlike anything else we know. So what could have knocked a planet 4 times the size of Earth onto its side? The leading theory is as violent as it is simple, a colossal impact. Astronomers suspect that in the solar system's chaotic youth, a protoplanet at least twice the mass of Earth slammed directly into Uranus. This was not a glancing blow, but a head-on collision so immense it literally shifted the planet's rotational axis, setting it spinning on its side. The evidence for this cataclysm may be frozen in time. Unlike the other gas giants, Uranus does not radiate much more heat than it receives from the Sun, suggesting its core was somehow deactivated or stripped of its primordial energy, possibly by the same impact that reoriented it. This titanic crash could also explain the planet's strange collection of moons and rings, all of which orbit in that same tilted plane, as if the entire Uranian system was forged in that single shattering event. Yet, this giant impact theory, while compelling, is not without its own mysteries. Why is Uranus's magnetic field so askew, tilted 60 degrees from its rotational axis and offset from the planet's center? It is a magnetic field that seems to be generated by a slushy, electrically conductive ocean of water and ammonia deep within the planet, a dynamo that operates in a way we do not fully understand. The extreme tilt of Uranus presents a fundamental puzzle about the formation of planetary systems, a reminder that the history of our cosmic neighborhood is written in violence and that some of the most dramatic events are frozen in the spin of a world. The Sun holds a secret written in fire, a paradox that defies our basic understanding of heat. If you were to fly a spacecraft toward the Sun, you would logically expect the temperature to climb steadily as you approach its blazing surface. Yet the reality is bizarrely inverted. The Sun's visible surface, the photosphere, is a searing 10,000 degrees Fahrenheit. But as you rise above it into the wispy outer atmosphere called the corona, the temperature doesn't drop, it skyrockets, soaring to millions of degrees. This is the coronal heating problem, one of the most enduring mysteries in all of solar physics. How can the Sun's atmosphere be hundreds of times hotter than the surface below it? It is as if the air around a flame was suddenly hotter than the fire itself. The key lies not in traditional heat, but in the Sun's invisible, chaotic magnetic field. The Sun is not a solid ball, but a churning plasma where magnetic field lines are constantly generated, tangled, and snapped apart. One leading theory points to a process called magnetic reconnection. Picture 2 powerful magnets being forced together. The magnetic fields suddenly snap, breaking and reconnecting in a new configuration. This explosive event releases a colossal amount of energy, like a miniature solar flare. Scientists believe the corona may be filled with countless tiny versions of these explosions called nanoflares, each one too small for us to see individually, but together creating a constant, invisible drizzle of energy that superheats the entire atmosphere. Another compelling idea involves magnetic waves. These are not ocean waves, but powerful vibrations rippling along the Sun's magnetic field lines known as Alfvén waves. Generated by the turbulent motion of plasma at the surface, these waves travel upward into the corona, carrying immense energy. As they travel through the thinner atmosphere, they can crash into each other or simply break, much like an ocean wave crashing on a shore, dumping all of their pent-up energy as heat. We see the evidence for this magnetic drama in the corona's stunning structures, the magnificent loops and arches that glow during a solar eclipse. These are not made of fire, but of superheated plasma tracing out the invisible lines of the sun's magnetic field. The fundamental challenge is that we cannot yet measure the magnetic field in the corona directly, and the nanoflares are too small and frequent to distinguish with current telescopes. Every solar flare we observe is a piece of this puzzle, a violent clue in a cosmic detective story about the hidden forces that power a star's crown. Dark streaks stain the Martian cliffs, appearing and vanishing with the seasons. These are the recurring slope lineae, narrow, dark tendrils that flow downhill for hundreds of meters during the warmest months, only to fade away when the temperature drops. Seen in stunning detail by the high-rise camera aboard the Mars Reconnaissance Orbiter, these features look for all the world like the work of liquid water, seeping from the ground and trickling down sun-baked slopes. They are the most compelling and controversial evidence that liquid water might still flow on the surface of Mars today. The debate over what creates them is a scientific tug of war between two fundamentally different visions of Mars. On one side is the water camp. Spectroscopic data from orbit suggests the streaks contain hydrated salts, minerals that can absorb water from the Martian atmosphere and lower its freezing point, creating a super salty brine that could remain liquid in the frigid Martian cold. This would be a monumental discovery pointing toward potentially habitable environments, places where microbes could theoretically survive just beneath the surface. The other side argues for a completely dry explanation: sand flows. In this scenario, the dark streaks are not wet at all, but avalanches of fine, dark sand grains sliding down bright, dust-covered slopes. The seasonal warming could destabilize the sand, causing it to cascade downhill and reveal the darker material underneath, creating the illusion of a darkening, flowing substance without a single drop of liquid involved. Each theory has its strengths and its flaws. If it is water, where is it coming from? And how does it persist long enough to flow without instantly boiling or freezing in the thin Martian air? If it is only sand, why do the spectral signatures sometimes hint at salts? And why do the flows follow such precise, repeatable seasonal patterns? The implications of the answer are profound. If the recurring slope lineae are wet, they would be the best candidates on present-day Mars for finding a habitable zone, a place where we might finally detect signs of life. This potential is so significant that it has directly influenced Mars exploration strategy, with rovers being carefully steered away from these sites to avoid any possible contamination from Earth. The dark streaks are therefore both a promise and a warning, a tantalizing hint of a living Mars that we are not yet allowed to touch, a mystery written in the shifting sands and perhaps the fleeting water of the red planet. Neptune radiates a fire that should have died out long ago. While the distant sun provides only a faint, cold light, this ice giant generates more than twice the heat it absorbs, warming its cloud tops from within. This makes Neptune an outlier, a world with a powerful internal furnace. Its near twin, Uranus, by contrast, is thermally lazy, radiating barely any excess heat at all. Why would two planets similar in size and composition have such dramatically different internal energies? The answer seems to lie in a violent beginning. Scientists theorize that Neptune experienced a much more chaotic and energetic formation than Uranus. It may have accreted more material from a denser region of the primordial solar system, with larger and more frequent impacts delivering immense heat that was trapped deep within its core. This primordial heat is still slowly leaking out billions of years later. Another critical process is gravitational contraction. As the planet slowly cools, its dense interior compresses under its own immense weight. This compression generates friction and heat, a steady trickle of energy from the core upward. Neptune might also be undergoing a form of internal differentiation, where heavier elements like oxygen, carbon, and nitrogen slowly sink toward the center through a slushy mantle of water, ammonia, and methane ices. This slow, relentless rainfall of material releases gravitational energy, converted directly into warmth. But why is this process so much more active in Neptune than in Uranus? The colossal impact that knocked Uranus onto its side may have been too catastrophic, perhaps scattering much of its internal heat into space or creating a stable, layered interior that effectively insulates the core, preventing the heat from escaping. Neptune, spared such a direct hit, may have retained a more turbulent, churning interior that efficiently transports its inner fire to the surface. This hidden heat engine drives the most powerful winds in the solar system, whipping methane clouds into supersonic storms. The mystery of Neptune's warmth is a lesson in planetary history, revealing that the scars of formation and the slow, billion-year-long settling of a world's interior can shape its climate and weather for eons. On the darkest, clearest nights, long after sunset or just before dawn, a faint, ethereal pillar of light can sometimes be seen reaching up from the horizon. This is the zodiacal light, a soft, triangular glow often mistaken for the first hint of morning or the last vestige of twilight. It is sunlight, not from the sun itself, but reflected from countless trillions of dust grains that fill the inner solar system, a vast, diffuse cloud stretching from the sun out past the orbit of Mars. For centuries, this gentle illumination was a celestial curiosity, but it has since become the center of a modern cosmic puzzle. We thought we knew where this dust came from, the constant grind of asteroid collisions and the dusty trails left behind by comets. These processes should, in theory, provide a steady rain of fine particles to maintain the cloud. Yet when scientists calculated the rate at which this dust should be falling into the sun or being blown out of the solar system by radiation pressure, they found a glaring discrepancy. The zodiacal light is too bright. There is simply too much dust lingering in the inner solar system, more than our best models of asteroids and comets can account for. Where is all this extra dust coming from, and what mysterious mechanism is constantly replenishing it? One provocative theory points the finger at the outer solar system. A slow, grand migration of dust from the Kuiper belt or the Oort cloud could be drifting inward over millions of years, a cosmic conveyor belt of ice and rock that steadily feeds the inner cloud. Another idea suggests that the asteroid belt itself is far more active than we assumed, with a population of previously unseen, dark and dusty comets, sometimes called main belt comets, periodically erupting and contributing their debris. There is even a possibility that a significant amount of this dust is interstellar, a gentle rain of particles from beyond our solar system, captured by the sun's gravity as we move through our local galactic cloud. The mystery of the zodiacal light is a reminder that even the most subtle, serene phenomena can hide profound questions. It is a ghostly presence in our night sky, a cloud of dust that should not be as thick as it is, silently challenging our understanding of the dynamic, dusty ecosystem we call home. Pluto's frozen heart holds a secret ocean. When the New Horizons spacecraft flew past this distant world in 2015, it revealed a stunning sight, a vast, bright heart-shaped feature stretching across the dwarf planet's surface. This is Tumble Regio, named for Pluto's discoverer, and its left ventricle is a basin of pure mystery, Sputnik Planitia. This sprawling plain, larger than Texas, is not made of rock but of solid nitrogen ice, a frozen sea as smooth as a skating rink and fractured into mysterious polygonal cells. The most compelling clue to its nature came not from its appearance but from its weight. Data showed that Sputnik Planitia creates a gravitational anomaly, a positive mass concentration, which means it has more mass than the surrounding terrain. How can a basin filled with lightweight frozen gas be heavier than the rock around it? The answer points to a colossal impact in Pluto's ancient past. A giant object, perhaps hundreds of miles across, is thought to have struck Pluto, carving out a deep scar. Over eons, this crater filled with volatile nitrogen ice from the atmosphere, but that alone would not make it heavy. Scientists realized the ice must be incredibly thick, and that the basin itself is still missing mass from the impact. This combination suggests something astonishing is hiding below, a dense, slushy ocean of liquid water, uplifted by the impact and now supporting the icy plain above it like a buoyant raft. Sputnik Planitia sits directly on the tidal axis between Pluto and its large moon, Charon, a position that is too perfect to be a coincidence. The gravitational tug of war between the two worlds likely caused the entire dwarf planet to reorient itself, rolling over until this massive, heavy feature settled stably opposite its orbital partner. This means Pluto's heart may have literally turned the world upside down. The possibility of a subsurface ocean, kept liquid by the heat from radioactive elements in Pluto's core, completely rewrites our understanding of dwarf planets. They are not just inert, frozen fossils, but dynamic worlds capable of hiding vast, liquid water oceans, and perhaps even the conditions for chemistry that could one day lead to life in the most unexpected places in the solar system. Even as distant Pluto hides a secret ocean, the sun-scorched world of Mercury reveals a planet that has been literally shrinking. Global maps from the Messenger spacecraft show a surface crisscrossed by colossal, cliff-like faults called lobate scarps. These are not ordinary hills, they are the wrinkles on a drying fruit but carved on a planetary scale. As Mercury's massive iron core cooled over billions of years, the entire planet contracted, causing its brittle crust to fracture and thrust upward, one section sliding over another to create these towering features. Some scarps stretch for hundreds of miles and rise over a mile high, a testament to a world cracking under the strain of its own cooling. The mystery, however, is one of scale. The sheer number and size of these scarps indicate a degree of global contraction that far exceeds what any standard model predicted. Mercury has shrunk much more than our theories of planetary formation and cooling said it should have. So what force squeezed this world with such unexpected violence? One possibility is that the early planet was even hotter than we thought, perhaps from a more intense bombardment of asteroids that delivered immense heat, or from a different initial composition that allowed its core to cool more dramatically. Another, more intriguing idea involves the planet's magnetic field. Mercury should be geologically dead, too small to retain the internal heat needed to power a magnetic dynamo. Yet it has a weak but persistent global magnetic field. This suggests its core may still be partially molten, churning in a way that generates the field while also contributing to a complex, multi-stage cooling process we do not fully understand. The planet's dramatic shrinkage forces us to reconsider the life cycle of rocky worlds. It paints a picture of Mercury not as a static relic, but as a dynamic, evolving body that has undergone profound physical change, its entire history written across its scarred and wrinkled face. While one icy moon near Saturn sends plumes into the void, another around Jupiter might be staging a similar, spectacular show. Europa, a world slightly smaller than our own moon, is encased in a cracked global shell of ice, but beneath that frozen crust is believed to lie a vast, salty ocean containing more than twice the water found on all of Earth. The Hubble Space Telescope has provided hints that this hidden ocean is not content to stay hidden. On several occasions, Hubble's keen eye has detected what appear to be faint, transient plumes of water vapor erupting from Europa's south polar region, reaching hundreds of miles into space. These are not the continuous fountains of Enceladus, but sporadic, elusive bursts, as if the moon is taking brief, gasping breaths. The evidence is tantalizing, yet maddeningly indirect, based on subtle dips in ultraviolet light as the plumes may briefly block the glow of Jupiter behind them. This has sparked a fervent hunt for confirmation. Scientists are using every tool at their disposal, from further Hubble observations to analyzing old data from the Galileo spacecraft, which may have flown through a plume without even knowing it. The implications of confirmation are staggering. If these plumes are real, they represent a once-in-a-lifetime opportunity for science. A future spacecraft could simply fly through one of these erupting columns and, without the immense difficulty of landing or drilling, taste the contents of the subsurface ocean directly. It could analyze the water for complex organic molecules, salts, and even potential biosignatures, chemical traces that could indicate life. Artist concepts paint a breathtaking picture: a robotic probe soaring through a sparkling, sun-lit geyser, collecting icy crystals that originated from a dark sea far below, a sea that has been isolated for billions of years. This is the profound promise of Europa's tentative plumes, a chance to explore an alien ocean not by penetrating its icy shield, but by catching a sample it has willingly thrown into the sky. But perhaps the most profound mystery is not within our solar system, but imprinted across the entire cosmos, a ghost from the very dawn of time. It is called the cosmic microwave background, the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. This fossilized light forms a nearly perfect blanket around us, and according to a fundamental rule of cosmology, it should be the same in every direction. The universe on its largest scales should have no center and no edge, no preferred direction or special place. This is the cosmological principle, the bedrock upon which our entire understanding of the cosmos is built. Yet, when scientists created exquisitely detailed maps of this background radiation, they found something that should not be there, an alignment so strange it was nicknamed the axis of evil. This axis is not a physical object, but a direction in space. Astonishingly, the plane of our own solar system, the flat disk in which all the planets orbit, seems to be aligned with certain large-scale patterns in the cosmic microwave background. It is as if the solar system's orientation is somehow linked to the structure of the infant universe, a connection that defies all logic and probability. The statistical significance of this alignment is what makes it so controversial. The patterns are there and the correlation is real, but is it just a fluke, a one-in-a-thousand cosmic coincidence that we happen to find because we are looking? Many scientists argue it must be a systematic error, an artifact of how we process the data, or perhaps even contamination from dust within our own galaxy that we have not fully accounted for. They point out that the universe is vast, and with enough data, some seemingly improbable alignments are bound to occur purely by chance. Yet the anomaly persists, refusing to be fully explained away. If it is real, the implications are staggering. It would suggest that our location in the cosmos is not entirely random, that there is a preferred direction on the grandest scale, challenging the very foundation of modern cosmology. The axis of evil remains an unconfirmed but deeply intriguing ghost in the data, a whisper that our most fundamental assumptions about the universe might be missing a crucial piece of the puzzle, a secret written in the first light of creation. From the ghostly whisper of the Wow signal to the silent, shrinking heart of Pluto, these 25 unexplained phenomena reveal a solar system brimming with secrets. Each one, from Mars's fleeting methane bursts to the impossible geometry of Saturn's hexagon, stands as a monument to our own curiosity. They are cosmic questions carved into the ice of distant moons, written in the magnetic ghosts of dead worlds, and hidden in the silent, dusty light of our own dawn. We have mapped the planets and sent probes beyond the sun's reach, yet our own backyard remains a place of profound wonder and mystery. These puzzles remind us that discovery is not about finding final answers, but about learning to ask better questions. The universe is not a static museum, but a living, breathing, and often bewildering puzzle. So we turn this final question to you: of all these cosmic riddles, which one captures your imagination the most? Is it the tantalizing possibility of life in Enceladus's hidden ocean, or the haunting, structured silence of the Wow signal? Share your favorite mystery in the comments below. We are genuinely curious to hear which cosmic conundrum keeps you looking up at the stars. If you enjoyed this journey to the edge of understanding, be sure to subscribe for more deep dives into the wonders that wait just beyond the light.